Welcome to Excel Business Math Series number 31. Hey, we're in the workbook Business Math Chapter 3. If you want to download this, go to my YouTube channel, then click on my college website link, and you can download this workbook. Otherwise, if you're enrolled in the class, just go to our Chapter 3 website. Hey, we're talking about increase and decrease problems. We just got done talking about rate of change, which is totally related. We talked about rate of change and increase and decrease. Now we're going to go to a little bit harder increase and decrease problem. Let's read this question. After spending $3,450 for tuition and $4,350 for dorm fees, Edgar finds that 35% of his original savings remains. Find the amount of his savings that remain. Well, at first it may seem confusing, but we have two tricks up our sleeves. We'll just start listing some variables, whatever we can extract from the problem, and then we'll try drawing a picture too. So after spending, so I'm just going to put tuition, and that was 3450. Enter, and then we had dorm fees, and that was 4350. Did I get that right? Yeah. And then it says Edgar finds that 35% of his original savings remains. Well, okay, original. Oh, well, original, that sounds like begin, right? That's what we started with. So let's put that here, original. And that's savings, and I'm going to put equals begin, because that's the term we're using, begin. And we don't know what that is yet. Then it says Edgar finds that 35% of his original savings remains. Well, if you have a bank account and you have 35% left, that's associated with whatever's left over. Oh, and the amount left over is the end. So, and down here it says find the amount of his savings that remain. I'm going to put goal, find amount of savings that remain. And the amount that remains is actually the end amount. So I'm going to put that right here, equals end. Now wait a second. They didn't give us this one. Wow, what are we going to do here? Well, this is where, and did we get all the information? We got that one, that one. Yeah, we got all the information. That's not very much information, but let's draw a picture. Now look, oh, we didn't write down the rate. So the rate, which is in our case equal to percent of savings that remain. And I'm going to put rate here. I'm also going to put, this is the base, just in case we like to relate it. And this is the part. And we haven't figured out exactly what that is yet, but that'll become obvious in just a moment. Let's go ahead, and we've got to put 35% here, and then we'll draw a picture. I'm going to use some colors here. I can tell that 35% is less than 50, so we used more than half of our savings. So I'm going to maybe take 3 cells, and then I'm going to use maybe from the home ribbon like a yellow. And then right below, to associate a little smaller square, because this will be our 35%, I'm going to do some orange. And since we need to find our total amount, or at least that is one way we can do it, let's put some color right here. Oh, yeah. We've gone down, right? We had this, we're way below where we started. So even though we haven't gotten our minus yet, that tells us this is a decrease. Hey, this is a big decrease, right? And in that case, when we look at our pictures, we know that we started with some base amount and we went down to here. Now, in fact, before we go any further with this drawing, we can actually go over to our PDFs. I have a nice little drawing about an increase problem here. We have our end part, our base, our rate of change and rate. Now let's look at a decrease problem. Oh yeah, as we talked about before, the base is the whole amount, and then this is some decrease, right? And then you end up with this. right? So in this problem right here, it's huge. There's a big rate. We already did this one. It was 88% left. But in our case that we're solving right now, it's 35. So this little section here is going to be a lot smaller than the decrease. Here's the base. So that's kind of what we're doing here. Now we could probably fill some of this in. Let's use a little. Well, first off, we can just come over here and say equals 35%, right? So the rate, and I could put rate here, rate. The rate associated with this little chunk right here is 35%. And we know from that picture that this is the rate of change. Better come out negative when we calculate it. Now let's think about this. Let's see if we can. We don't quite have enough room. Let's write our formulas out here. So our goal is to find the amount of savings. We don't quite have enough room, so I'm going to write my formula right here. Rate of change. Now think about this. Our rate of change, we were using begin end divided by begin minus 1. But we saw another way to do it also. If we know the actual rate, remember, let's jog our memories, right? If we knew this rate, it would be easy to get this, right? Because we could just subtract the rate and subtract from it 1. In fact, we had that written down earlier in when we first defined these formulas as an option. So guess what? We could type rate minus 1. And so we could actually calculate this here. We know our rate, there it is, minus 1. And sure enough, it comes out negative. So because we have a big drop. So I'm actually going to right here say equals and get that number right there. Hey, what's that? They put up a fence. I'm going to double click that so it gives us a little bit more room there. Now, the next thing we can. So now, the next thing is amount of change. We already know what that is. Equals, in our case, they're just giving it to us. We actually have to add these together. So I'm going to say tuition plus dorm fee. And then here I'm going to alt equals, which is the keyboard shortcut for AutoSum, and it's guessing wrong, but we know how to redirect it. Now, I would like this to show up as a negative because we've talked about how this should be a decrease. If we had other information, we'd solve it and get the negative directly, but we don't here. I'm going to hit F2 to put this in edit mode, and if I put my cursor after the equal sign but before the sum, I can type a minus, and it will change that to a minus. Now look at this. Now we can start filling out our picture. Amount of change, enter, and I'm going to say equals this. Now, here's the whole trick to this problem is noticing, and we've talked about this, and I've chose my language carefully, associated part, associated rate. Once you know either one, and it doesn't matter if it's the amount of change and rate of change or the end amount and the associated rate, regardless which one it is, once you have two of them and they're matched up, you can solve for the begin amount or base. So I'm going to say base equals begin equals, and I'm going to write this just like this, part divided by the rate, but I'm going to use the terms we're using. Amount of change divided by rate of change. No, don't be scared of this. This is just a part and a rate. That's why I decided to call this rate of change instead of percent of change. Now, here it is. We just do it. Equals. Oh, and dividing a negative by a negative. Remember, even in English, a double negative is a positive. So we're going to take our part divided by our rate, and we get 1,200. Now, I'm going to apply a little formatting there, and there. Control-Shift-4. Same with here, Control-Shift-4. Hey, what are all those fences? Let's expand our columns. Ooh, yuck. Control-1. I don't mind those, but maybe some of you do. I remember the first time I saw them, and I didn't know anything about accounting. And I was like, what is that parenthesis? And the accountant that was talking to me said, what, are you dumb? You don't know what parentheses mean? I went, no, I don't. So we'll keep it like that for now. All right, so now we have our begin amount. The original question, oh, actually, let's do this. Begin, enter, and I'm going to say equals and get this. That way our picture is filling out nicely. Let me scoot over here. So we have all of our associated rates. The only thing we need left is this, because the question says how much of the original savings remain. Well, here we have our rate, and rate times our begin amount or base will give us the end amount. So part, which also equals end in our case, will equal the begin times the rate. And we saw in our increase problems how we had a rate greater than 1, so we went up. In this case, this is much less than 1. So when we multiply that by this, it's going to be much smaller. Equals the begin times our rate. 4,200. So the amount we have left, and this will be the end amount. I'm just going to put end equals this. Wow, that is cool. We have this cool little picture with all of our stuff. Now we just need to check and then write an answer. All right, so we're going to check, and there's lots of ways we can check this. Let's check it by taking these two and divide them and see if we can get our begin amount. So I'm going to take the part, which is end in our case, divided by the rate. And that better give us our begin amount equals our, and you can take it from over here if you want, n divided by our rate. Ding, 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 ding. So we checked it there. And you could check it a couple other ways. Let's go ahead and write our answer in words. The amount of amount of savings that remain. 4,200. All right, so the trick there was getting to the fact that we had an associated part and associated rate. We solved for this, and then it was easy once we got that. All right, now let's move on and do our second increase-decrease, which will be an increase of Iowa farmland. Increased 4.3% this year to a statewide average of 1,857 per acre. How much per acre did the Iowa farmland increase this year? Round to the dollar. So there's an example where I'm going to tell you to round, and so you have to. All right, let's write some variables here. The value of farmland increased this year by that percent. Well, that certainly sounds like our rate of change. And that's going to be increase in property value. And that was 4.3%. I'm going to format as I type by typing that percent in. Rate of change. What else were we given here? Oh, we know the end amount. So the end equals value at end of year. And that's 1,857. We could actually format as we type 2. And this will be end. How much per acre did the Iowa farmland increase? So we want to know the amount of change, which is going to be equal to amount land increased. They tell us that it increased. So we know this is an increased problem right off the bat. Hey, what are the formulas? We have the rate of change and our end amount. We're going to do a few things. Let's start by drawing a picture, just like we did before. Looks like, ooh, there's only a little teeny, so I'll use one cell right here. And I'm going to use a green, some sort of light green or something. Boop. And that's the amount of the increase. And then we'll maybe use that many. It's not exactly proportional. And we'll use a dark green, zip, like that. So we're given the percent, and we know the end amount. Now, watch this. This is going to be the part. the part over here, we start with this much, right, and we go up by that much. So this whole section over here, we'll pick the darkest green we can find. We better put some light color. So for this and this, if we're going to draw pictures, we better select a font. Well, right off the bat, we know the rate of change. Whoa, whoa, whoa. Uh-oh, this column right here is a little bit, I'm going to shrink this down. Shh. All right, and this is going to be rate of change. And we know this right here, this is our n. Notice that it comes up in white, equals that. Now, if it's not obvious from the things we have so far, let's just mess around with some pictures. Let's think about this. This is our base. We don't know how much that is yet, but we do know one thing. Base is always 100. So I'm actually going to add some color here. And I'm going to put 100%. Now, as we saw earlier in our drawings, whenever we have the 100% and our rate of change, whether it's negative or positive, when you add those two together, you get your rate. So get this. Here's our end amount, and it's an increase. So that means the rate is going to be greater than 1. So I'm going to come over here and add a little color. Again, I'm just trying to solve a hard problem however I can, even if it takes some visuals on the side. This is going to be rate. Oh, and I can add these together. If this was negative when I added it, it would be less than 100%. It would be a decrease. But it's not. This is an increase. So I'm going to say equals this plus this. And there's our rate. Hey, look at that. I better come up here and double click. Now I'm going to come up here and actually write some formulas. This was our goal. Our goal is still to find the amount of change. I'll put amount of change here. And our first idea about this is we know we didn't expressly write this formula here where we add these two together, but we do remember this. Rate of change equals the rate minus 1. Now, if you look at this, if you know a little algebra, if we added 1 to this side, added 1 plus negative 1, that would give us 0 on this side, and then added a 1 to this side, then we'd be left with 1 plus this equals our rate. And that would be a formal formula for us. So rate of change plus 1 will always equal our rate. Now, we didn't specifically write this formula down, but our drawings definitely led us to this conclusion. And that's the trick to this one. So, and we did it right there. So now we can go ahead and start solving. Now, I'm actually going to come down here and formally in our setup, I'm going to do this formula right here. And let's try it. Equals our rate of change plus 1. Hey, but wait a second. Over here, we added these two together. Yeah, that's right. Actually, that it took the percentage format. But watch this when we hit, oh, and we have the percentage format right there. Actually, let me zoom this down just a little bit. It's not quite fitting on the screen. How about 102? Still can't see that over there. I'm going to change the format, Control 1. I'm going to not show 3. I'm just going to show 2. Right, so we have this shown as a percent. But what if we really did want it as a rate? Of course, we would go back to general format, and that would be the number 1.043. We have it listed here and here. We know from our study of decimals and percents that this one has that number underneath, but this has the format. All right, now here's the next trick. We have a rate and an associated part. Now, don't let the fact that this is bigger and this is the end and this is the rate and it's bigger than 1, it's still a rate and an associated part, so we can easily calculate our base or begin value. So base equals begin equals, and we have an associated part, P divided by our R. Now I'm going to go ahead and write this out, or we can do that, P divided by R, or in our case, it's N. Remember, N can be part divided by our rate. And let's do that. Equals, and there's our end amount. We can take it from up there. We could actually take it from right here, too. But either one, that divided by our associated rate right there. And what do we get? $1,780.44. Oh, but that's the begin amount. There's still one step left, and that is the amount of the change. Well, if you know where you ended up and you started, the amount of change will equal our end minus our begin. So we'll say equals our end minus our begin. There it is, 76.56. Ding, ding, ding. That's not the right answer. Let's remember our, that's always worth a lot of points on the test, knowing how to round. Oh, round to the dollar. So now we're going to have to remind ourselves from earlier chapters how to round. Whatever the calculation is, you just put the round function around it. And guess what? We're not rounding to the penny because we know the second argument in round would be 2 for pennies. We're doing it just like taxes. It's to the dollar. And so we put a 0. All right, so 77 bucks. Now we can check this. Let's check, and be careful when you're checking with rounded numbers because you won't get the exact answer. I'm going to check method 1 here. I'm going to take this calculated begin amount, and I'm going to see if I can multiply it by this. Or actually, why don't we multiply it by that and see if we can get our one of these original amounts. So I'm going to say the end amount equals, and that's the part, begin, which is base, times our rate. Now let's see if this works. Equals, we have our begin number times our rate. And that makes sense, right? The begin number is less. In an increase problem, it's always going to be 1 plus some extra. Or it could be huge gain. That would be 2 or 3 times that. So it should give us this. And when we hit enter, sure enough, looks like we're on the right track. Now we can write our answer in words. And we'll just steal from here. How much per acre did the Iowa farm? So I'm just going to come up here. Actually, we don't need to do that. I'm just going to say the land increased by 77 bucks. And in parentheses, I'm going to say that is given our 4.3% increase. All right, and so that is a couple problems for increase and decrease. And the trick here was a couple things. But one is this idea of drawing a picture to help you solve the problems. And also the idea that anytime you have a rate and the associated part, here we had the rate of change and the amount of change. And in this problem, we had the rate and the end amount. But if you know those two things, you can solve for the begin amount or the base. All right, when we come back, our last video for this chapter will be markup and markdown. See you then.